Good afternoon, Anna. What, Miss Crackle? I'm fine only. What happened to me? Yeah, good afternoon. Yeah, in the previous class, what we discussed, I think some work in, yeah, thank you. Okay, good, thank you. Uh, Here, I think previous one, yesterday, what I uploaded, in that I think I explained about, ah, apparent weight. Yeah, exactly, you're right, Ishan. So here, just like if you are interested, we try to solve few more models related to the work energy. Okay, first based on work, right? Mm, Suppose here related to the work concept. Uh, if we discuss one question here, yeah, correct, lift model only. So here, if you come to one example related to the work energy power, that is related to work only first. Here, what he said in one numerical. Good afternoon, Anna. A person pushes a box. Here on a rough horizontal platform. Box as shown. Better I write here. Right? How sir? Like this. um, Suppose if I take one platform here, and on this platform, uh, this is rough surface. A box is placed. This is one box. A person pushing this box by applying some force. How much, sir? Take something here like 200 newtons. Okay, he applied 200 newtons there. And after what he said here, after covering a distance of 15 meters, means he pushed with the 200 newtons through a distance of 15 meters. Okay, after covering a distance of 15 meters, um, he reduces linearly with the distance, means he reduces the force linearly with the distance, means variable force he applied distance to what amount he reduces, sir. He reduces the force from 200 to 100 newtons, means linearly while going forward he decreased the force from 200 newtons to 100 newtons. Okay, so after 15 meters the force is variable and that is decreasing with the distance. Okay, keep in mind. So what is the total distance traveled, sir? Already traveled 15. Okay, the total distance traveled, he said, is 30 meters. Means further it traveled 15 meters, Nana. First 15 meters, constant force. Next 15 meters, variable force. Changing from 200 to 100 linearly. Okay. Then here, what is the total work done by the person? This was one question, Nana, previously given in exam, of course. Then here, how to solve this type of question? Okay. I think anybody can say here up to first 15 meters, what is the work done? First part, that is very simple. First part, if you observe from here to there, very simple, here to there. This is take it first 15 meters. Okay. And this part you take it as next 15 meters. Okay, Nana. So first 15 meters I'm seeing here, this is 15 meters. The force is constant. Happily, I think you can solve. This is 200 newtons. Displacement is 15. So what will be the work done here, Nana? W1? I think you can say 3000. Yes, F into S. Exactly, Ishan. Correct. And Srestha, you are right, I think. 3000. Yeah, correct. So this is the displacement, direction of displacement, constant force. Both are in the same direction. Happily, you can say W1 is equals to F into S. Yes, correct. That is equals to 200 into 15. That is equals to 3000. First part is over. This is very simple. Total 5250, Nana? Yeah, maybe correct. Right? Here, second part, how to solve, Nana? If it is so, if your answer is correct. Manikanta? Second part, how to calculate? Integration method. Okay, right, good. Here, how you took that force? Second part. In the case of second part, the force, how much you took here? This is again 50 meters. That is correct. But how much you took the F value, Nana, to find out the work done? Half in 200 plus 100 by 2, na. Right. 200 plus 100 by 2 entra. Where is the integration? Manibabu? Mani Babu. Mani Babu. Okay, right. Then here, anyone has the idea, Nana? How to take the force in second case? F2. MG na. Are Ishan Babu, what happened, ra? MG acts downwards, ra. Force is applied like this. This is the force, ra, nana. Ayyo. Right. Try to understand properly, nana. What he said here, observe. He reduces the force linearly. So you have to say some linear equation here with the distance. Okay. Linearly decreases with the distance means actually force I have to write directly proportional to distance. Means yes. Okay. Force is directly proportional to S. That too decreasing means F is equals to, I have to write, since it is decreasing, okay. Actually, I have to write some K into S, nana, constant. Okay, na? Right? And it is decreasing from 200 to 100. Means if you put S is equals to 15, you have to get F is equals to 200. There it is 200. If you put F is equals to 30, you have to get F is equals to 100. Why? Because at S is equals to 15 meters, F is equals to 200 newtons. At S is equals to 30 meters, F is equals to 100 newtons. Okay. So accordingly, you have to say what is the equation for the force. Okay. Right. So since the force is decreasing from 200 to 100, first of all, I have to take minus kx. S is increasing from 15 to 30, but force is decreasing from 200 to 100. Decreasing, negative. Okay. And number two, sir, here, if you see, sir, I put 15 here, sir. Okay, Nana. That is equals to minus k into, yes, I put 15 there, sir. You are saying that F should be 200. Okay, Nana. What next you are saying? If you put S is equals to 30 here in this equation, in your assumed equation, linear equation, minus k into 30, you should get this is 100, sir. Okay. Sir, if you check here, yes, correct, Nana, Lakshmi Gayatri. As the force is decreasing, I took minus k. If force is increasing, means this is just like force and displacement, a straight line, Nana. Like this. Oh, what happened? If it is like this, force is increasing with the displacement, then the slope what I took here, k is positive. That k part only I am explaining here, Nana. I should first I try to complete so that you can understand, not yet completed here. Okay. Actually, you are getting, if you see in the FS graph, Nana, force is decreasing with the displacement means it is appeared like force is decreasing with the displacement. Force value is decreasing with the increase of displacement. The graph, if you take, you will get like this, Nana. For this is type of straight line, what is the equation in your mathematics? Y is equals to minus mx plus c, na? Am I right? Is it correct? Yeah, that's what I'm going to conclude here. Yeah, force is decreasing with the increase of displacement. With the increase of displacement, force value is decreasing. That's why according to mathematics, I should get a graph or the equation for the straight line. Y should be equals to minus mx plus c. That's I'm concluding here. Y equals to minus mx. So extra I have to write plus c. Okay. So plus some constant I have to write here. Sir, what is the K value, sir? I don't know. What is the C value, sir? I don't know. Then how you calculate, sir? Simple. Two unknowns are there, two equations are there. You can't solve it. You can solve it, solve them. How, sir? Simple. Subtract the two equations. Oh, yes, correct, sir. 200 minus 100, that is 100 is equals to minus K into 15 minus 30. Subtracting none. CC cancel. I am getting 100 is equals to minus K into 15 minus 30 is minus 15. I am getting K value is equals to 100 by 15. That is equals to 520 is a 53 is a. K is equals to 20 by 3 I got. Okay, sir. K is 20 by 3. Then what to do, sir? You have one more unknown. C. That one to calculate, substitute the K value, whatever you got, you substitute in any one, first equation or second equation. Okay, sir, better we substitute in the first. Okay, as you wish. That implies substitute here 200 is equals to minus K is 20 by 3 into 15 plus C. Look at here, how much is this? 3 5s 25 is 100. That implies C is equals to 200 minus taken to the other hand plus 25 is 100. So C is equals to 300. Finally, I got the equation for the force nana. What? Y is equal, sorry, F is equals to, finally I got here, that implies F is equals to minus Kx 20 by 3 into X plus C. C is 30. X means yes here. Okay. Now, if you have any doubt, you can ask. Do you have any doubt in my explanation getting the linear equation here for the decreasing force? Now, anyone can raise the doubt. Right. Good. This is the way how to calculate the linear equation for the force. Why? Because he clearly mentioned he reduces the force linearly with the distance. If it is increasing with the distance, happy we can write y is equals to like mx plus c or y is equals to mx and directly we can calculate. Yeah, good, good, good. Okay, now you can go. Since the force is varying with the displacement, work done, second part, W2 is equals to, since it is variable, you go through the integration, F dot ds. Look at force and the second displacement here, both are in the same direction or not? Force and the second part, the displacement, both are in the same direction or opposite direction or making some angle? Same. That's why here in the dot product, I can put cos 0, same direction. Yeah, that implies W2 is equals to integral, yes, correct. F, I'm going to substitute 20 by 3 into S plus 300 all to, oh my goodness. Better I write like this. Minus 20 by 3S plus 300 F dot ds. ds cos 0. Yeah. Now you try to integrate, Nana. That is minus 20 by 3 S into ds plus, okay, splitting rule, Nana. integral 300 ds. I think you still remember the integration. If there is a constant, that can be taken out. Minus 20 by 3 integral s ds plus 300 is constant integral ds. So this is minus 20 by 3 into s integration is s square by 2 plus 300 into integral ds is, anyone remember, Nana? Integral dx is x. Yes, right. Here integral ds is yes. Now look at the limits. This variable is 4. This force is variable from 0 to 30 or 15 to 30. Means from 15 meters to 30 meters or 0 to 30 meters. Force 15 to 30. Very good. Very good. Right. So I have to substitute the limits from 15 to 30. That implies W2 I am getting here is equals to minus 20 by, I take that 2 also out, Nana. 2 3s are 6, constant. And s square means 30 square 900 minus 15 square 225. Okay, first the upper limit minus lower limit. I think you remember how to substitute the limits. Plus, I am writing here 300 into first upper limit 30 minus lower limit, that is 15. So you are getting here minus 20 by 6 into 900 minus 225. How much, Nana? 6. Right, good. 675 plus here we are getting 300 into 15. Okay, if you cancel 2 tens are, 2 threes are, again here 3 twos are, 3 twos are, 3 fives are. Okay, so if you see here minus 2250 plus this is 15 threes are 45, 4500. After subtracting, how much you get, Nana, there? Minus 2250 plus 4500 means 4500 minus 22050 కదా Nana. So 0 5 and 5 to 5 minus 4 minus 2 2 and this is 2, correct? Yes 2250, correct. So second part you are getting, this is 2250 after subtracting, you are right. Therefore, total work done, he asked, that implies W is equals to W1 plus W2. W1, how much we got, Nana? Where is it? 3,000. Right. 3,000 plus 2250. That is equals to 5250. Yeah, good. But once you check the procedure, Nana, is it not appear to be lengthy? Yeah, that's what I'm saying. Very lengthy or not, the procedure. Okay. That's why here sometimes, if you know the limits provided, if you know the limits, like here in this problem, what is the advantage you got? F 15 meters at 30 meters, what are the limits of forces? You know, it reduces from 200 to 100. You know the limits. Okay. In that case, happily here, if you try to calculate using the graph method, sometimes the graph methods are very useful to solve the problem in a shortest way, Nana, like a shortcut. That's why once you observe how simply we get the answer, yeah, graph method. So here, if you see the graph method, means the method 2, I'm saying. To solve the same problem. This is method 1, lengthy procedure. Okay, Look at the second method. You will get in very simplest way. The answer you will get, Nana, here. How, sir? Just check it. First, this is the force I am taking on the x-axis, sorry, y-axis, and the displacement I am taking on y-axis. And I am checking there. When the force is 200, constant force, I got a displacement of 15 meters. That I draw in the graph. Okay, sir, force is 200, sir. Yes, force is 200. Okay, note it, sir. 200. Constant force, sir? Yes, constant force. So force won't change. So you will get a straight line like this, constant force. Up to what displacement, sir? From 0 to 15 meters. Oh, up to 15 meters, sir? Yes, up to 15 meters. I applied a constant force. Okay. Now all of you understood, Nana, how I drew this graph? First part you understood? Yes, very good, very good. Next, look at what he said. The force, sir, reduces from 200 to 100, sir, linearly, sir. Reduces. Luckily, in the first method you told already here how to decrease that force linearly. The shape of the graph you already told, sir, here. It will be a straight line, almost appearing like intersecting both the axes. Yeah. So here force decreases linearly. Second part, from 200, from here to 100. Okay. Oh, sir, force is decreased from where to where, sir? 200 to 100. Oh, here the force is 100, sir? Yes. This is 100. Okay. What is the displacement, sir? You know, in the question he gave up to 30 meters total. Okay, decreases linearly, yes, sir? Yes, in the question only he gave decreases linearly. Okay, straight line correct only, sir. Okay. Now what he is saying, work done is, since it is equals to force into displacement, appeared like the y-axis into x-axis in the graphs of motion in a straight line. Y-axis into x-axis gives area or slope, Nana? Y-axis in, right. Y-axis by x-axis gives? Y-axis by x-axis? Yeah, good, slope. Y-axis into x-axis gives area. Okay. Since the work done is equals to force into displacement, it is appear like multiplication or division, Nana? Y-axis into x-axis, na? Yeah. Y-axis into x-axis means I have to take the area. Yes, yes. So for FS graph, you can say the concept here, what, since W is equals to F into S, the area under F force and displacement graph, not force minus S, Nana. Force and displacement. Better I write here, otherwise you may get confused. Force and displacement graph gives the work done. Okay, so simple here. If you come to that graph model, we took FS graph, sir, and F into S is the work done, sir. So if you are able to calculate what is here the area under the graph up to here, what is this much area? If we are able to calculate this area, up to what distance, Nana? He is asking total work done. total work done means up to 30 meters. Okay. If you are able to calculate this total area, then you will get the total work done. That is very simple. Appeared like, suppose if I take the points A, B, C here, better I take like this. This is one rectangle, this is one rectangle, this is one, right. A, B, C, this is the point D, this is the point E, this is the point F, and this is the point A, B, C, D, E, F, G. This is the point G. Okay. Why I gave them, I think you understood. First look at O, G, C, D, Nana. Area of OGCD. This is a rectangle. I think you can say, yes, OGCD rectangle, length into breadth. So length is 30 into breadth is 100. Yeah, right. So length is 30 into breadth is 100. That I am getting here 3000. Next, you can take it like a trapezium or else part of triangle and rectangle. That is your wish. Suppose if I take it as area of AGFB. This is also rectangle, Nana. Right. A rectangle here. Yeah, even by that method also we can do. You did in trapezium model, Amok, but I am doing like a rectangle plus triangle. Okay, right. Here rectangle, yeah, rectangle. What is the length here, Nana? GF 15, yeah, and length into breadth 100 to 200 means this is 200 minus 100, 100. AG is 100. So this is equals to 1500. Yeah, correct. Then area of triangle. Area of B, F, and C. Area of triangle. This is a half base. Base is 15 to 30. This is 15. Into height, already you told 100 to 200. That is 100. Okay. So if you cancel here 250s, you will get here 750. Okay. If you add all, you will get 50 here. This is 2 and 3, 4, 5. 5250 you are getting after adding. Is it correct, Nana? Okay. Just in one part we completed. Okay. Like just one half of the screen. Okay. Whereas you see there 1, 2, 3 and 1/4. 3 1/4 screens it took to get the answer, or 3 screens, 3 half screens it took to take the answer. Okay. Really it is not the shortcut or not? I think it is method 2 is comfortable for you all. Yes. Method 2 is the best one. Right, good. But we have to come to know what is the original method. That's why I explained the original method also. Okay, the original method and the shortcut for objective exams. Okay, this is the shortcut. Okay, sir. You are intelligent, sir, Manikanta. That's why you took from the graph only. Okay, good, no problem. Right. Okay, then come to here. One more example. Okay. Suppose if I say here, this is also related to the graph, Nana, how to find the work done. Okay. He said previously in exam that consider a force, okay, given that F bar equals to minus xi cap plus yj cap. Okay, like some coordinates, x and y are the coordinates. In those coordinates, he said. Okay. Then what he is asking, find the work done in moving a body from where to where, sir? Since he said force like in coordinate system, x comma y, he said the coordinates in moving a body from one, sorry, from 1 comma 0 to 0 comma 1. He is asking. Okay. Take all these in meters and that is in newtons. Okay, so means he is asking, say the answer in joules. That's it, what he is saying. Okay. For this here, how to solve? If you ask, means simple, Nana. He is moving from 1 comma 0 means initially it is on x-axis. Finally, he moved it to 0 comma 1 means y-axis. From x-axis to y-axis, he is moving with this variable force. Okay. Force is varying with the coordinates now. Okay. That's why surely you have to go to the integration now. Right. Whereas displacement given in the x comma y coordinate system now. That's why to find out the work done, I assume like this. Once you observe, if you have any doubt, you can ask. Since the force is variable, I am going to first W is equals to integral F dot ds. First thing. And number two, number two, the force is given in coordinate points. The displacement I write here ds bar as actually s is equals to, we write like xi cap plus yj cap, Nana, but force is given like that. That's why the displacement ds bar, I write it as like dx I cap plus dy j cap. Okay. Whereas force already given here as xi cap plus yj cap. Now, do you have any doubt in my assumption? Any doubt, Nana? No, sure. Yeah. Xi. What is Shrestha? You to put the answer here. I did not understand. Okay. Then the xi cap only, Nana. Here I wrote na xi cap plus yj cap. This is I cap only, not j cap. Yeah, xi cap. This is not j, Nana. Oh, minus x. Okay, okay, okay. Thank you, thank you, thank you. Minus xi cap plus yj cap. Right, right, right. Then accepted here. Then we are taking here first to integrate. Before the integration, we have to take the dot product of two vectors. Why? Because we assume both in vector form. So dot product f bar dot ds bar. Dot product, all of you know. I cap coefficient into I cap coefficient, that is minus x into dx. 0 na. What 0 ra? Plus here what ka? No re. y into here j cap coefficient, that is y, into j cap coefficient is dy, y into dy. So I got the dot product as f dot s equals to minus x dx plus y dy. Now you can substitute in the work done. That implies w is equals to, I will get integral f dot ds, that is minus x dx plus y dy. Okay, so I think you can, you know how to integrate this one. Anybody can say by splitting method first, minus x dx integral plus integral y dy here. What is this integration? You can say minus x square by 2, correct, Anana? It's integration. Plus, yes, y dy is y square by 2. It's integration. Good. This is the work done. Now, x and y coordinates already he gave here. How to substitute? Started from 1, 0 to 0, 1. So now in the next page, I'm going to substitute the limits. That implies w is equals to what I got, minus x square plus y square. Since both I got divided by 2, after taking LCM, whole divided by 2 in the limits from x-axis 1, 0 to 0, 1. 1, 0 to 0, 1. Okay. First substitute upper limit. In place of x coordinate, that is 0, y coordinate is 1. Substitute here. So first x coordinate 0 minus 0 square plus 1 square by 2. Upper limit is over, Nana. Minus lower limit I am substituting here. Okay. Here I am getting, this is first minus 1 square, okay, by 2. Oh, very good, very good, very good. You are getting 0 na answer. Here this is, I am getting half. Oh, not 0 na. Minus of plus, yeah, minus of minus plus I am getting here. 1 by 2. I am getting 1 so na. Is it 0 or 1 na? I think I am correct. Yeah, right, good. So here, this is 1 joule. All of you understood the method, Nana, what I explained? Any doubt? Okay, no problem. Yes, very good, very good. Okay, then simple. I will give one question, Nana. Try to solve it by tomorrow or in the next class. Okay, or for the new year, that is your wish. The next class or in the new year, you try to complete it. The question is, okay, right. Here he is saying that one block is placed on the inclined plane at Nana, okay, which is making an angle theta. But problem is here, half of the plane is smooth and remaining half is rough. That is the problem, Nana. Okay. Of course, not half exactly. What he said like this. This is the one. This is the inclined plane. Making an angle of inclination, some theta there. This is the angle of inclination. Okay. And he said this is the point A and this is the point B. And somewhere he gave the point C. Okay. Suppose I take the point C here. Why? Because he said BC part is 2 times to AC. That's why BC is more, AC is less. BC is 2 times to AC. Okay. And he said when a block is left freely from here, okay, a block, sorry, is left freely, okay, at B, okay, finally it comes to rest, means keep in mind, started from rest, left freely means U is equals to 0, started from rest. Finally, it comes to rest at A. Okay. Angle of inclination, already I gave it as theta. Okay, Nana. Now till here you understood? And he said that it is smooth and AC part is rough. Clearly he mentioned this is rough. Okay. Just he is giving there coefficient of friction at the surface AC is mu. Take it as mu, Nana. Okay. And problem is here the mu is changing with theta, Nana. Okay. Or else simply I say here after coming to the bottom means A, it comes to rest means given that mu is equals to final after solving he got k tan theta. Then k is equals to how much? Means simply what he is asking when it comes to rest at A, find out mu, Nana. That is simple one to understand. Now you understood the question, Nana? This is smooth. It is rough. Yeah. Means I will give some hint also. Total length, suppose if you take it as 3L from top to bottom, you can take this is 2L and that is L. Okay. Why? Because BC is 2 times 2. Yeah. It slides down, gets some velocity here, and then decelerates and comes to rest here. Okay, Nana? Then mu is equals to how much? For mu, you will get some answer, Nana, like some 3 into tan theta or like some 3 by 4 into tan theta, you will get the answer. Then that k value is how much he is asking, whether it is 3 or 3 by 4 or 2 or 1 or blah, 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 some value. Will you solve this one, Nana? Shall I leave it to you all? Yeah, good. It's possible you try to complete this in this year only. Okay, don't postpone to it to the next year. Okay, good. Do you want the pages, Nana? Thank you, Nana. Thank you. Yeah. Come to Aditya here. This is first page. Yeah, thank you, Deepali. Again, don't ask after moving to the next pages. This is first page. Once again, I'm saying.